Welcome to Academic Math. Today I would like to solve question number 8 of the book Higher Algebra by S.K. Mapa. Exercise 1. Before solving the question number 8, I would like to discuss something, that is symmetric difference. About symmetric difference. What is the symmetric difference and how does it look? So the symbol for symmetric difference A, symmetric difference B is this, and it is defined as the union of A difference B and B difference A, and its Venn diagram is here. Suppose this is A, set A, and this is set B. Then the shaded portion, that is I am drawing here, this is the symmetric difference, A symmetric difference B. The shaded region is the symmetric difference. Actually it is the difference of A union B, difference A intersection B from A union B, that is A intersection B. If we differentiate the intersection portion or zone from the union zone, then we will get the symmetric difference. Now in question number 8, it is given that A symmetric difference B equals C and I is the universal set. It is given that symmetric difference B equals C and I is the universal set, and we have to prove that first question is A equals B symmetric difference C. A equals B symmetric difference C. B symmetric difference C. Now I will start from the right hand side as B symmetric difference C. If we put the value of C, which is given here, and which is A intersection B, B symmetric difference A symmetric difference B, which means by the definition of symmetric difference, B difference A symmetric difference B union A symmetric difference B difference B. Okay, and we know that if we differentiate the symmetric difference from B, we will get nothing but A intersection B, because from the Venn diagram of the symmetric difference here, it is clear that we have to differentiate A symmetric difference B, that is the shaded portion. We have to differentiate the shaded portion from B, then there will exist only this portion in B. The remaining part of B is A intersection B, because A intersection B is the subset of B, and this portion will remain after the differentiation. That is, if we differentiate A symmetric difference B, that is the total shaded region which are horizontal line, and if we differentiate the horizontal line from B, then the vertical line will remain in B. That is why we will get the A intersection B from this portion, and from the next part and from the next portion we have to differentiate B from A symmetric difference B. If we differentiate B from A symmetric difference B, we will get A difference A intersection B. We will get nothing but A difference A intersection B. Now here A intersection B is not, and here is A intersection B. If we know that A intersection B is a subset of A as well as subset of B, and therefore A intersection B is in A. If we subtract, or that is if we make difference of A intersection B from A, then the intersection portion will not exist here. If we finally add this by the union, then we will get nothing but A, and which is our LHS. Is that this clear to all of you? I think it is clear, because it is not so hard or so critical, I think. Now I will solve the question number 2 of 8 of the question 8 in the next page. Question number 8 2. Here it is also given that A symmetric difference B equals C and I is the universal set. Okay, and we have to prove that B equals C symmetric difference A. Now C symmetric difference A can be written as, by putting the value of C that is given, or which is given, A symmetric difference B symmetric difference A, and by the definition of symmetric difference it becomes A symmetric difference B difference A union A difference A symmetric difference B, and which is equals to, now we have early in the previous page we have seen that the Venn diagram of the symmetric difference, and it is clear from the Venn diagram that if we subtract A from the asymmetric difference B, then we will get B difference A intersection B union. If we subtract asymmetric difference B from A, then we will get A intersection B, and which is nothing but B, which completes the proof. Now I would try to make it clear from here that if we try to draw the Venn diagram of the union of two sets, A is the set eta, this is the set A and this is the set B, and this portion is known as A difference A intersection B, and this portion is A intersection B, and this portion is B difference A intersection B, and which is also equals to A difference B. If we make the difference B from A, the results will be equal to the same of differentiating A intersection B from A, and similarly it will be equal to B difference A, that is B difference A and B difference A intersection B have the same type of meaning. Okay, if we differentiate A from asymmetric difference B, then we have to differentiate this portion, and we have to differentiate this complete portion, that is the complete A, from the symmetric difference, and then we will get the vertical zone here. That is, by coloring we can, this portion will be the common portion. If we differentiate A from the asymmetric difference B, then from the asymmetric difference B, if we differentiate B A, then it will remain B difference A. Sorry, we have to differentiate A from the symmetric difference. The symmetric difference portion is this portion and this portion, and we have to differentiate A, that is complete A, then it will remain this portion also, and which is our B difference A intersection B, which is our this portion. Is that clear or not? Actually, this video I am unable to streaming right now due to some YouTube privacy and policies, so I can't get the response from the students right now. Now I would like to go to the next question, to solve the next question in a similar way. And which is our question number 3 of question 8, and here it is also given that asymmetric difference B equals C, and I is the universal set. And we have to prove that A intersection B union C equals A. Now to prove this, we will start from the left hand side, and which is our A intersection B union C. Putting the value of C, it will look like A symmetric difference B. And which equals A intersection B union, and by the definition of symmetric difference we can write it as A difference B, the union of A difference B, as the union of A difference, as the union of A difference B union B difference A, which equals A intersection, if we take union B, A difference B and B difference A, 3 union B, there does not exist any intersection right now, so we can omit the first bracket from here and write it as A difference B union B difference A. We also know that the symmetric difference is the zone this shaded zone is the symmetric difference. If we take B with here, this is A and this is B, and therefore the shaded zone, this shaded zone together form A symmetric difference B. If we take union with this, take union of B with A symmetric difference B, then we will get the total whole set, because A intersection B is there, because A intersection B is exist in the set B, and therefore it will become A intersection A union B, and which is nothing but A. Got it? And which is our left hand side, and which completes the proof. Now in the next page I will solve question number 4, that is In this question, it is given that B intersection C union A equals B. This is given that B intersection C union, we have to prove that. This is not given, sorry, this is not given. We have to prove that B intersection C union B, prove that PT, prove that this, and given that A symmetric difference B, A symmetric difference B equals C, and I is the universal set. Now, to prove this, we will first write the left hand side and put the value of C, which is A symmetric difference B, which is A symmetric difference B. B intersection C union A can be written as B intersection A symmetric difference B union A symmetric difference B union A by putting the value of this. If we take union to the symmetric difference of A symmetric difference B with A, then we will get A union B. We do not need to distribute this, that is the symmetric difference, because from here it is clear that from the diagram we can make it clear that it will be A union B, because we know that the diagram of symmetric difference, this is the set A and this is the set B, and sorry, this is not visible, and this portion, this red zone is the symmetric difference. Total red zone is the symmetric difference, and A is the first part, first set is the A and second set is B, and if we take union this red zone with A, then we will get A union B, because the intersection which is exist in A will included into the symmetric difference, and therefore it will become A union B. And therefore B intersection A union B, and which is nothing but B, which completes the proof. Question number 5. Of question 8. This is also similar to the previous. Here we have to show that, prove that, we have to prove that C intersection A union B equals C. Now we know that C is the symmetric difference. It is given that C equals given that C is the symmetric difference. C is the symmetric difference of A and B, and therefore, and I is the universal set, it is common, universal set, and therefore we have to prove this. We will start from the left hand side, and which is C intersection A union B, and A union B can be written as C intersection A symmetric difference B difference A symmetric difference B union A intersection B, and which is equals C intersection A intersection B is C, and which is C union A intersection B, which equals C intersection C union C intersection A intersection B. And which is C union phi, and which equals C. Hence completes the proof. Because C intersection A intersection B is phi. Why this is phi? Because A union B together is A symmetric difference B is the red zone here, and which is A symmetric difference B. If we take intersection this with A intersection B, then we will get nothing but phi. C is equivalent to A intersection B, and C is equivalent to A asymmetric difference B. Sorry, C is equivalent to asymmetric difference B. Thank you. I think it will help to solve the question number 5 questions of question number 8 of the book Higher Algebra by Mapa. All the students are requested to complete each and every mathematics that is given to the exercise of this type of books, and there exists a such type of books which is known to me is written by Malik, Morrison and Sen. First, I would like to try to solve this Mapa book, and after that I will try to solve the exercise solutions of the book Malik, Morrison and Sen. All are requested to pray for me so that I can complete my wish, that is complete my all solution to the problems of the exercise. Okay, thank you.